Let's continue right along with number 20 from page 720 for our chapter 10 review. The snowboarding rail shown is an arc of a circle in which BD is part of the diameter. If arc ABC is about 32% of a complete circle, what is the measure of arc AB? The measure of arc AB will be equal to half the measure of arc ABC. And this is because the diameter will split this arc in half, since it's perpendicular to this chord. So we need to figure out what ABC is. It says that ABC is 32% of a complete circle. So the measure of ABC is equal to 32% or 0.32 times an entire circle. 32% of 360. That gives you 115.2. So substitute that back in here. We can figure out what AB is because it's going to be half of ABC. So let's take half of 115.2. And my answer is 57.6 degrees. From the same page, number 27. Roberto is designing a logo for a friend's coffee shop according to the design at the right, where each chord is equal in length. What is the measure of each arc and the length of each chord? So if all four chords are congruent, then that means that all four arcs are congruent. So I just need to take 360 and divide by 4 to get my first answer. Which gives me 90 degrees. Also, if I split this square in half, I would have 90 here. And then that would be 45. Whoops. Maybe I should write it down here. So I'm splitting the square in half. I have my right angle. And I have 45 degrees for these other two angles, half of 90. So I've got a 45, 45, 90 triangle where the hypotenuse is the same as this length over here. So that's going to be 3 feet. And at a 45, 45, 90, the legs are congruent. And to find a leg, you take the hypotenuse and you divide by the square root of 2. That's the rule for a 45, 45, 90. Take the hypotenuse and divide by the square root of 2. So that's going to give me the length of one of these chords here. So just go to your calculator and type in 3 divided by the square root of 2. And you should get approximately 2.12 feet. So that's my second answer. Number 20. Find the measure of angle C. What do we know? We know that angle C, its sides intercept this arc AB. Is there another angle that intercepts the same arc? Yes. Angle D does. Anytime you have two inscribed angles, whose formed by two chords whose vertex is on the circle, and they intercept the same arc, okay, that arc being AB here, then those two angles will be congruent. So I can set these two expressions equal to each other and solve for y. So subtract 5y from both sides. add 7 to, let's see, 4y, something isn't right here, whoops, I'm sorry, I did that backwards. Subtract 4y from both sides, that's better. Add 3 to both sides, and y is equal to 10, but we want to find the measure of angle C. The measure of angle C is this expression, 5 times y, so 5 times 10 is 50, minus 3 would be 47 degrees. Number 24, find the measure of angle T. What do we know? We know that RT is the diameter, because it's going through the center. So anytime you have a diameter and then a triangle formed off of that with an inscribed angle, that inscribed angle is going to be 90 degrees because the intercepted arc is 180. It's a semicircle. So if we have a right triangle here, then we know that the corollary to the triangle sum theorem states that the acute angles must be complementary, so this angle and this angle must add up to 90 degrees. So if 3x is equal to 90, simply divide both sides by 3, and x is equal to 30, but we're not done yet. We want to find the measure of angle T. The measure of angle T is 2x, so 2 times 30 is 60 degrees. Okay, this next problem comes from page 727. It's number 10. Find the measure of angle C and the measure of angle D. We have an inscribed quadrilateral. An inscribed quadrilateral is a four-sided polygon with each of its vertices on the circle. So the circle goes through each vertex. Whenever that's the case, we know that opposite angles will be supplementary. So we can solve for y by setting 3y plus 4 plus 2y plus 16 equal to 180. Likewise, we can set this sum equal to 180. So we have 58 plus 2x is also equal to 180. Now let's solve these two equations. So for the top equation, 3y and 2y is 5y, plus 4 and 16 is 20. Subtract 20 from both sides, and 5y is equal to 160. And divide both sides by 5. And we should get y is equal to 32. For the other equation, we will subtract 58 first from both sides, and then we'll divide both sides by 2, and x is equal to 61. Now we should be able to substitute these values in and solve for C and D. So C is equal to 2 times x. What is x? X is 61. And now we have 122 degrees for that answer. We also want to find the measure of angle D. What's the measure of angle D? It's 2 times y, where y is 32, plus 16. So this would give us 64. And the sum is 80. Similar type of problem on page 728, number 30. Find the measure of angle G. To find G, first we have to figure out what y is. We have an inscribed quadrilateral, so opposite angles are supplementary. So 3y plus 9 and 4y minus 11 must add up to 180. Those two angles are supplementary. So we get 7y minus 2 is equal to 180. Add 2 to both sides. 7y is equal to 182. Divide both sides by 7. Y is equal to 26. But you're not done yet. Substitute that back in to find the measure of angle G. So 4 times 26 minus 11 is 93 degrees. Next we have number 12 from page 736. Copy each figure and draw the common tangents. If no common tangent exists, state no common tangent. A tangent is a line that intersects a circle in exactly one point. Common tangent, so if you have more than one circle, that line is going to intersect both circles, each at exactly one point. So we could draw a line across the top like that. Intersecting the circle at one point here and this circle at one point there, and likewise across the bottom. Intersecting the circle at one point here and this circle at one point right there. So there would be two common tangents. Page 737, number 22. Find x. Assume that segments that appear to be tangent are tangent. Round to the nearest tenth if necessary. So FE is tangent. It intersects the circle at exactly one point F, and DE is tangent. One point there, D. So for this type of problem, we have a theorem that states two tangents to the same circle from the same exterior point will be equal in length. So these two tangent segments will be equal in length because they're from the same exterior point E, exterior outside of the circle. So anytime you see a problem like this, you're going to set those two tangents equal to each other. So let's just subtract 2x from both sides. Let's add 4 to both sides. And let's divide both sides by 4. Therefore, x is equal to 1. This problem is also from page 737. It's number 25. Find the value of x, then find the perimeter. We're using the same concept here. So to find x, I have a tangent to the circle here and a tangent to the circle there. Since those two tangents are from the same exterior point B, then they have the same length. So how can I find this right here? Well, I know, same concept, there's a tangent, and there's a tangent from the same exterior point A, so those two will have the same length. So I have 5 centimeters for AM. I know that AB is a total of 13 centimeters, which forces MB to be 13 minus 5, or 8 centimeters. If MB is 8 centimeters, then so is BN, 8 centimeters. And that goes for all of these tangents from the same exterior point. So 7 and 7 here, 6 and 6 there, 5 and 5 right there.